When your diaphragm contracts, the pressure in the chest cavity is lowered below atmospheric pressure and air is forced into your lungs. We have a diagram of the lungs and the chest here. The dotted line you see gives the position of the diaphragm before it contracts, and you can see that the volume of the lungs are smaller, and then it moves down, so the volume is increased. Then the question states the diaphragm contracts and the lung capacity increases by 20%. So we have an increase in the volume. State two assumptions you would need to make to calculate the new pressure in the lungs if the initial pressure is known. So what we have here is a change in pressure, and we know the initial pressure. Also the volume changes. Since we are dealing with air and the changing properties of air, we would need to make use of the ideal gas equation. PV is N KT. And if we have a look at this equation, we can see that P and V are the ones that are changing. And if you want to make use of this, we will need to have the others fixed in the equation. Otherwise, we would have too many variables and not be able to calculate. So the fact that the others need to stay fixed is going to be our assumptions. So if we look at those terms, we have T there. So we need to assume temperature is fixed. And we have also got N, which is the number of particles. So we need to also assume that the mass, which is determined by the number of particles there, is fixed. Well, another assumption is that to be able to use this equation in the first place, we need to assume ideal gas behavior.